Good morning, my dear students. We are now in our lesson for week 3 in quarter 1. I am Teacher Eleanor, your teacher in General Mathematics. Okay, let's begin. Now, bring out your learning activity sheet. Be sure that you're in a comfortable learning area. Always prepare your notebook where you can write down your notes about our topic. Since our subject is math, be sure to have your answer sheets. From our previous lesson, we discussed how to represent real-life situations using rational functions, how to distinguish rational function, rational equation, and rational inequality, and how to solve rational equation and rational inequality, and how to find the domain and range of a rational function. In the modules and video lessons, these topics were presented and explained with different examples. In this week, the learning competencies are determine the intercepts, zeros, and asymptotes of rational functions, and then solves problems involving rational functions, rational equations, and rational inequalities. An intercept of a rational function is a point where the graph of the rational function intersects the x or y axis. To find the y-intercept, which is the point where the graph crosses the y-axis, we substitute 0 for x and then solve for y or f of x. And to find the x-intercept, which is the point where the graph crosses the x-axis, is also known as zeros. We substitute 0 for y and then solve for x. Let us have illustrative examples. Find the intercepts of the function given f of x is equal to x plus 10 over x minus 5. To find the y-intercept, we must substitute 0 for each x. So we have f of x is equal to 0 plus 10 over 0 minus 5. And then we simplify. F of x now is equal to 10 divided by negative 5. So we have negative 2. So there is a y-intercept at 0, negative 2. To find the x-intercept, we must substitute 0 for y or f of x. So we have 0 is equal to x plus 10 over x minus 5, and then solve by cross multiplying. 0 times the quantity of x minus 5 is equal to x plus 10 times 1, which is equal to x plus 10. 0 times x minus 5 is 0, is equal to x plus 10. Then we solve for x, so we transpose 10, so we have x now is equal to negative 10. So there is an x-intercept at negative 10, 0. Let us have our example number 2. Find the x and y-intercepts of f of x is equal to x squared minus 5x plus 4 over x squared minus 4x minus 1. So we have the first step. We let y equal to 0 in finding the x-intercepts. So we have 0 is equal to x squared minus 5x plus 4 over x squared minus 4x minus 1. Then we cross multiply. 0 times the quantity of x squared minus 4x minus 1 is equal to x squared minus 5x plus 4 times 1 at the right side, which is equal to x squared minus 5x plus 4. Then we have 0 times the quantity of x squared minus 4x minus 1 at the left side is equal to 0. Then we just copy the right side as x squared minus 5x plus 4. Then to solve for x, we factor the trinomial x squared minus 5x plus 4 as the quantity of x minus 4 times the quantity of x minus 1. Then, if x minus 4 is equal to 0, then x is equal to 4. And if x minus 1 is equal to 0, then x is equal to 1. Thus, the x-intercepts are at 4, 0 and 1, 0. To get the y-intercepts, we let x equal to 0. So we have f of x is equal to y, then y is equal to x squared minus 5x plus 4 over x squared minus 4x minus 1 as the given. Then we substitute 0 for x. So we have y is equal to 0 squared minus 5 times 0 plus 4 over 0 squared minus 4 times 0 minus 1. Then we simplify the right side. 0 minus 0 plus 4 is equal to 4 over 0 minus 4 minus 1 is equal to negative 1. Then 4 divided by negative 1 is negative 4. So thus the y-intercept is at 0, negative 4. The zeros of a function. The zeros of a function are the values of x which make the function 0. The real numbered zeros are also x-intercepts of the graph of the function. In general, when dealing with rational functions, whatever value of x that will make the numerator 0 without simultaneously making the denominator equal to 0 will be a 0 of the said rational function. So we have steps in finding zeros of rational functions. Number 1. Factor the numerator and the denominator of the rational function if possible. Number 2. Identify the restrictions of the rational function f. The restrictions are the values of the independent variable that make the denominator equal to 0. 3. Identify the values of the independent variable that make the numerator equal to 0. And number 4, the zeros of the rational function f are the values of the independent variable that make the numerator 0 but are not restrictions of the rational function f. Let us have our example number 1. Find the zeros of the rational function f of x is equal to x squared plus 6x plus 8 over x squared minus x minus 6. So, the first step is we have to factor the numerator and the denominator of the function. So, the factors of the numerator are the quantity of x plus 2 and the quantity of x plus 4. And then the factors of the denominator are the quantity of x plus 2 and the quantity of x minus 3. So, we identify the restrictions. So, if x plus 2 is equal to 0, then x is equal to negative 2. And if x minus 3 is equal to 0, then x is equal to 3. Negative 2 and 3 make the denominator equal to 0 and they are the restrictions. Then we have to identify the zero of the function. If x plus 2 is equal to 0, then x is equal to negative 2. It will not be a zero of the given function because it is also a restriction. If x plus 4 is equal to 0, then x is equal to negative 4. So, x is equal to negative 4 will be the zero of the given rational function. So, let us have our example number 2. Find the zeros of the rational function f of x is equal to x minus 5 over x squared minus 25. So the first step, we have to factor the denominator. So we have f of x is equal to x minus 5 over the factors of the denominator, which are the quantity of x plus 5 and x minus 5, because it is a difference of two squares. Then, next, for the second step, we have to determine the restrictions. So we use the factors of the denominator. If x plus 5 is equal to 0, then x is equal to negative 5. And if x minus 5 is equal to 0, then x is equal to 5. X is equal to negative 5 and x is equal to 5 are the restrictions of the given functions. Then for the third step, if x minus 5 is equal to 0, then x is equal to 5. And x is equal to 5 is also a restriction. Therefore, the given rational function has no 0. So let us have an asymptote. An asymptote is a straight line with a curve such that as a point moves along an infinite branch of the curve, the distance from the point to the line approaches 0 and the slope of the curve at the point approaches the slope of the line. It is a line or a curve that the graph of a function gets close to but does not touch. How do we find the vertical asymptotes? Find the values of a where the denominator is 0. If this value of a does not make the numerator 0, then the line x is equal to a is a vertical asymptote. To get the horizontal asymptotes, we let n be the degree of the numerator and m the degree of the denominator. In n is less than m, the horizontal asymptote is y is equal to 0. If n is equal to m, the horizontal asymptote is y is equal to a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. If n is greater than m, there is no horizontal asymptote. So let us have our examples. Find the vertical and horizontal asymptotes of f of x is equal to 3x squared minus 8x minus 3 over 2x squared plus 7x minus 4. To get the factors of the numerator and the denominator, so we have the first terms of the binomial factors of the numerator will be 3x, because the first term of the numerator is 3x squared, and then over 3, because the numerical coefficient of the first term is 3. Then at the denominator, the first terms of the binomial factor are both 2x, because the first term of the denominator is 2x squared, and then over 2, because the numerical coefficient of 2x squared is 2. And then next, we have to get the binomial factors. We have to multiply at the numerator, we have to multiply the numerical coefficient of 3x squared and the last term negative 3. So we have 3 times negative 3 is negative 9. So now, what are the factors of negative 9 whose sum is negative 8? So we have 9 and 1. And then the middle term, negative 8x, has negative as a sign. So therefore, 9 will be negative and then 1 will be positive. So negative 9 and positive 1 are the second terms of the binomial
factors of 3x squared minus 8x minus 3. Then, at the denominator, to get the second terms of the binomial factors, we have to multiply again 2x squared and negative 4, or the numerical coefficients of 2x squared and negative 4. So we have 2 times negative 4 is negative 8. Now choose two factors of negative 8 whose sum is positive 7. So we have 8 and 1. Then the sign of the middle term of the denominator is positive. Therefore, the greater factor 8 is positive than the second factor, or the second term will be negative. So we have 8 and negative 1 as the second terms of the binomial factors of 2x squared plus 7x minus 4. Then next, we simplify to get the final factors. So we have 2 factor 3x minus 1. By common factoring, the common factor is 3. 3x divided by 3 is x. Negative 9 divided by 3 is negative 3. Times the second factor, 3x plus 1 over 3. And then next, we have at the denominator, the common factor of 2x plus 8 is 2. 2x divided by 2 is x. 8 divided by 2 is positive 4. Times the second factor, 2x minus 1 over 2. So the final factors now of the numerator and the denominator are, at the numerator, we cancel 3 and 3. So what is left now is the product of 3x plus 1 and x minus 3. Then at the denominator, we cancel 2 and 2. So what is left now is the product of 2x minus 1 and x plus 4. So if 2x minus 1 is equal to 0 as the first factor of the denominator, then x will be equal to 1/2. And then if x plus 4 is 0, then x will be negative 4. 1/2 and negative 4 do not make the numerator 0. Therefore, these are the vertical asymptotes. The polynomials in the numerator and the denominator have equal degree. Therefore, the horizontal asymptote is the ratio of the leading coefficients. Then we have example 2. Find the vertical and horizontal asymptotes of f of x is equal to 3x minus 9 over x squared minus x minus 6. So we have f of x is equal to 3x minus 9 over x squared minus x minus 6 as the given. So we have to factor the numerator and the denominator. Then the factors of the numerator are 3 and the quantity of x minus 3 by common factoring. Then the factors of the denominator are the quantity of x minus 3 times the quantity of x plus 2. So if x minus 3 is equal to 0 in the denominator, then x is equal to 3. If x plus 2 is equal to 0 as the second factor of the denominator, then x is equal to negative 2. X is equal to 3 makes the numerator 0. Therefore, it is not a vertical asymptote. But x is equal to negative 2, does not make the numerator 0, so it is a vertical asymptote. Then the degree of the numerator is less than the degree of the denominator, because the degree of the numerator is 1 and the degree of the denominator is 2. So it is less than the denominator. So therefore, the horizontal asymptote is y is equal to 0. So let us have our example number 3. Find the vertical and horizontal asymptotes of f of x is equal to x squared minus 2x minus 3 all over x plus 4. So first step, we have to factor the numerator and the denominator of the right side. So the factors of x squared minus 2x minus 3 are the quantity of x minus 3 and the quantity of x plus 1. Then you just copy the denominator because it is a prime polynomial. Then, if x plus 4 is equal to 0, then x is equal to negative 4. Negative 4 is a vertical asymptote since it does not make the numerator 0. Then the degree of the numerator is greater than the degree of the denominator. Therefore, the given rational function has no horizontal asymptote because the degree of the numerator is 2 and the degree of the denominator is 1. So we have the steps in solving word problems involving rational function, rational equation, and rational inequality. The first step, we read the problem carefully and determine what is asked. Number 2, use any well-known formula that is applicable to the problem. Number 3, translate key phrases that is applicable to the problem. Number 4, use sketches or tables to clarify relationships among variables and to form equation. Number 5, you solve the equation. Number 6, check your answer by substituting it into original equation. Then number 7, interpret the results clearly with appropriate units. Let us now solve problems involving rational functions, rational equations, and rational inequalities. Example number 1. Find two consecutive integers such that the sum of 1/3 of the first and 1/4 of the second is 9. So we have the solution. First step, we have to represent the unknowns. Since we are looking consecutive integers, so we represent the first integer as x and the second integer as x plus 1. But if the given is consecutive even integers, you will represent the first integer as x and the second even integer will be x plus 2. But since we are looking only for consecutive integers, so therefore, we represent the first integer as x and the second integer as x plus 1. Then next, we have to formulate the equation. So the underlined phrase in the given statement, the sum of 1/3 of the first and 1/3 of the second is 9. So you are going to translate this into an equation. So we have 1/3 of x plus 1/4 of the second integer x plus 1 is equal to 9. So 1/3 of the first integer is represented as 1/3 times x, and then 1/4 of the second integer is represented as 1/4 times x plus 1. And then, the result is 9. So, the LCD is 12. So, this is the first step in solving a rational equation. Then next, we multiply all members of the equation by 12. 12 times 1/3 of x is equal to 4x because 12 divided by 3 is 4 times x is 4x. Then 12 times 1/4 times x plus 1 is equal to 3x plus 3 because 12 divided by 4 is 3 times x is 3x. Then 3 times 1 is 3. And then at the right side, 12 times 9 is 108. Then next, we combine similar terms. 4x plus 3x is 7x plus 3 is equal to 108. Then we transpose 3 at the right, so it is changed to negative 3. So we have now 7x is equal to 108 minus 3. 108 minus 3 is 105. Then to solve for the value of x, we divide the two sides of the equation by the numerical coefficient of 7x, which is 7. 7 divided by 7 is 1 times x is x. 105 times 7 is 15. So x now is equal to 15, which is the first integer. And then the second integer is represented by x plus 1. Therefore, we just substitute x for 15 or 15 for x. So 15 plus 1 is equal to 16. So the consecutive integers we are looking are 15 and 16. So we have our example number 2. The denominator of a fraction is 2 more than the numerator. If 1 is subtracted from both numerator and denominator, the resulting fraction has a value of 1/2. Find the original fraction. The denominator is being described in the given problem. Therefore, we let our x as the numerator and x plus 2 as the denominator. So, the original fraction is x over x plus 2. Because in the given problem, it described that the denominator is 2 more than the numerator. So, it is x plus 2. Then next, we have to formulate the formula or the equation. So, we have to translate the underlined statement into an equation. If 1 is subtracted from both numerator and denominator, the resulting fraction has a value of 1/2. So therefore, the equation now is x minus 1 over x plus 2 minus 1 is equal to 1/2. So we have to cross multiply to solve for the value of x. So we have 2 times the quantity of x minus 1 is equal to 1 times the quantity of x plus 1. 2 times the quantity of x minus 1 is equal to 2x minus 2, applying distributive property. And then at the right side, 1 times x plus 1 is equal to x plus 1. Then we combine similar terms, so we have 2x minus x is equal to 1 plus 2. 2x minus x is x, and then 1 plus 2 is equal to 3. So the value of x is equal to 3. So the original fraction is represented as x over x plus 2. So now we substitute 3 for x in the expression of the original fraction. So we have 3 over 3 plus 2, and 3 plus 2 is equal to 5. So the fraction now is 3 over 5. Let us have our example number 3, which is a work problem. June can clean a room in 4 hours, while Anna can clean the same room in 3 hours. Working together, how long will it take them to clean the room? So first, let us represent the unknowns. If June can clean a room in 4 hours, what part of the room June can clean in 1 hour? So it is 1/4. If Anna can clean the same room in 3 hours, what part of the room Anna can clean in 1 hour? So it is 1/3. If X is the number of hours they will finish together working the room, what part of the room Anna and June can clean in 1 hour together? So it is 1 over X. So the equation now is, you have to formulate the equation by translating the underlined statement into an equation. Working together, how long will it take them to clean the room? So we have the part of the room June can clean in 1 hour plus the part of the room Anna can clean in 1 hour is equal to the part of the room Anna and June can clean in 1 hour together. So we have 1/4 plus 1/3 is equal to 1 over X. So the LCD of the rational equation is 12X. And then now we multiply all members of the equation by 12X. So we have 12X times 1/4 is equal to 3X because 12 divided by 4 is 3 times X is 3X. 12X times 1/3 is equal to 4X because 12X divided by 3 is 4X times 1 is 4X. And then 12X times 1 over X is equal to 12. Because 12X divided by X is, we cancel X and X, what is left is 12 times 1 is 12. Then 3X plus 4X is 7X is equal to 12. Then to solve for the value of X, we divide the two sides of the equation by 7. Then we cancel 7 at the left. So what is left now is X is equal to 12 over 7 or 1 and 5 over 7 hours. So Anna and June can clean the room if they will work together. They will finish it in 12 over 7 or 1 and 5 over 7 hours. Let us have our example number 4. A box with a square base is to have a volume of 8 cubic meters. Let X be the length of the side of the square base and H be the height of the box. What are the possible measurements of a side of the square base if the height should be longer than a side of the square base? So we have the solution. The volume of a rectangular box is the product of its width, length, and height. Since the base of the box is square, its width and length are equal.
The variable x is the length of a side of the box, while h is its height. The equation relating h and x is 8 is equal to x squared h, because the volume of a box is length times width times height, and the square is the base of the box. Expressing h in terms of x, so we obtain h is equal to 8 over x squared. Since the height is greater than the width, h is greater than x, and our inequality will be 8 over x squared is greater than x. To solve this inequality, we begin by rewriting it with 0 on one side. So we have
8 over x squared minus x is greater than 0. Then we simplify the left side. The LCD is x squared. X squared divided by x squared is 1 times 8 is 8. X squared divided by 1 is x squared times negative x is negative x cubed is greater than 0. Then we have to factor the numerator at the left side. So we have the quantity of 2 minus x times the quantity of x squared plus 2x plus 4. Applying what you have learned on how to factor a difference of 2 cubes over x squared is greater than 0. The rational expression will be the 0 for x is equal to 2 and undefined for x is equal to 0. So you plot on a number line and use hollow circles since these values are not part of the solution. Because if you substitute 2 and 0 in the given inequality, they will not satisfy the given inequality. So we have the number line now, and we will use a hollow circle or an empty circle. So we have our number line and we have empty circles at 0 and 2 because they do not satisfy the given inequality. Then we have to construct our table. So we have x is less than 0. So let us try negative 2. So we substitute 2 minus negative 2 times the quantity of negative 2 squared plus 2 times negative 2 plus 4 over 2 squared is greater than 0. Then the quantity of 2 plus 2 times the quantity of 4 minus 4 plus 4 close quantity over 4 is greater than 0. Then we simplify again the left side. So we have 4 times 8 over 4. Then you cancel 4. So what is left is 8 is greater than 0. So the given is a true statement, meaning the numbers which are less than 0 are solutions of the given inequality. Then we have 1 at the second column. So we try 1. So 2 minus 1 times the quantity of 1 squared plus 2 times 1 plus 4 over 1 squared is less than 0. Then we simplify the left side. So we have 1 times 7 over 1 is greater than 0. Then 1 times 7 is 7 over 1 which is equal to 7 is greater than 0. Again, it is a true statement. So meaning the numbers which are greater than 0 but less than 2 are solutions of the given inequality. Then we have the third column as x is greater than 2. So we try 3. Now we substitute the quantity of 2 minus 3 times the quantity of 3 squared plus 2 times 3 plus 4 over 3 squared is greater than 0. Then we have to simplify the left side. So we have negative 1 times 19 over 9 is greater than 0. Then we have negative 19 over 9 is greater than 0. So the given is a false statement, meaning the numbers which are greater than 2 are not solutions of the given inequality. So we have the next step. Since the rational expression is positive in the interval x is greater than 0 but less than 2, this is the solution set of the inequality. We reject the interval x is less than 0, even if the expression is true here, since we only consider positive values of x for the given problem. Therefore, the height of the box should be less than 2 meters. Let us see if you can identify the given statements, whether it is true or false. So tell whether each of the following is true or false. If the statement is wrong, change the underlined word to make it correct. Write your answer on the space provided before each number. Number 1. If n is greater than m, there is no horizontal asymptote. The underlined phrase is or word or words is n is greater than m. Number 2. To determine the vertical asymptote of a rational function, find the zeros of the numerator. The underlined word is numerator. Number 3. If n is less than m, the vertical asymptote is y is equal to 0. The underlined words are vertical asymptote. Number 4. The horizontal asymptote of f of x is equal to x over x squared minus 1 is y is equal to 1. The underlined word or words is y is equal to 1. Then number 5, the vertical asymptote of f of x is equal to the quantity of x minus 1 times the quantity of x plus 3 over x squared minus 1 are x is equal to 1 and x is equal to 2. So the underlined word or words are x is equal to 1 and x is equal to 2. Number 6, fill in the blanks. Blank is any function which can be defined by a rational function, an algebraic function or fraction, such that both the numerator and the denominator are polynomials. Number 7, an inequality which contains a rational expression is blank. Number 8, an equation containing at least one fraction whose numerator and denominator are polynomials is called blank. Okay, who will volunteer to answer item numbers 1 to 8? Okay. Very good. The correct answers are number 1 is true, number 2 is denominator, number 3 is horizontal asymptote, number 4 y is equal to 0, number 5 x is equal to negative 1, number 6 rational function, number 7 rational inequality, and number 8 rational equation. So now, your performance task is you solve the given problems involving rational functions, rational equations, and rational inequalities. It will be peer tutoring. Your partner must come from the same barangay. If you have no classmate in your own barangay, you may contact your classmates coming from adjacent or nearby barangay since it is pandemic time. You can chat your partner and talk about how you are going to solve the given problems. You help one another in solving the given problems. Show your complete solutions in each item. Send outputs through Messenger. Those who have poor internet connection, your parents will submit your answer sheets on the submission day. Number 1. The numerator of a fraction exceeds its denominator by 4. If 6 is added to the numerator and 2 is subtracted from the denominator, the resulting fraction equals 5. Find the fraction. Number 2. One printing machine can run the necessary copies for the daily circulation of a newspaper in 5 hours. A modern printer can run the same number of copies in 4 hours. How long will it take to run the copies when both machines are working? Your performance will be rated or graded based on the given indicators. Your rating will be 5 if all of the 4 indicators were satisfied, 4 if 3 out of 4 indicators were satisfied, 3 if 2 out of 4 indicators were satisfied, and 2 only 1 out of the 4 indicators was satisfied.
That is for today. I am glad that we finished 2 learning competencies from our lesson. Continue doing the activities in your learning activity sheet and accomplish your performance task. I hope you learned a lot from our discussion. Once again, this is Teacher Eleanor. I will end my discussion with this quote from Loyal Jack Lehman. Never stop learning, for when we stop learning, we stop growing.